Okay, we were reviewing probability. We'll go from the super easy to the super tough. All right, so here are some of the many strategies that you have to know. One of them, one of the easiest ones, was just you got marbles and they're in a bag, and you've got to figure out the probability that you draw out a green one and then a red one. Everybody try that, and hint, all you need is a couple fractions. And you should be asking me a question because it makes a difference on the second marble. Am I going to replace it? Good question. I am not. So the probability that you get, what did I say first? Green, then red. And again, I am not replacing that green marble. When I take it out, that changes your fraction for the other one. See what you think the answer is? Check with the kid next to you. Then I'm going to give you a follow-up question. Probability of red, then red, also without replacement. That's a trickier one yet. I'm going to pause while you figure out those two. Okay. Dice of Destiny. Let's see who's going to answer this question. It is row for person 6. Last person, that's you. S. Excellent. What'd you get for G, then R? First of all, what was the G one? Hint, it was 2 out of something. 2 out of 7. And then you times by, since I'm not replacing, 5 out of 6. Notice that that got lower on the bottom because I did not replace. Raise your hand if you guys did that one right. Awesome. Then the next one. Guys, don't talk back there. Next one is row 5, person 4. 1, 2, 3, 4. That's you. Yes, Mr. W. R, then R. 5 out of 7 times by 4 out of 7. 4 out of 6. How many of you agree with him now? Okay, good. Okay, so that's the kind where you just simply multiply fractions. There was a whole lot more kinds. All right, this next kind is not even probability, and yet it'll be on the probability test because it involves how many different ways you can do this. Okay, so it's like C's and P's. Okay, so let's do the C kind, just a simple C. I'm telling you ahead of time, they're not gonna on the test. I'm telling you ahead of time, this is a simple C. There are 30 of you. What's the probability? No, that's not a probability question. I want a ways question. There are 30 of you. How many different ways could I get little groups of 5? How many different groups of 5 could I get? Pausing for a second. Okay, 30, C5. Raise your hand if you had that one right. Okay, let's say that I changed the question just to see if you knew how to do this. A, C, B. What is the way you do that with factorials? You know what I mean? Like there's a factorial involved. Okay, I'm going to pause for a second while you try to remember. How do you do that by hand again? Because the calculator can't do that for you, can it? I'm going to pause for a second while you try that one. Okay, we got a lot to cover, so I can't give you too much time. A factorial over A minus B factorial. And then when it's a C question, you got to throw in an extra one of these. An extra B factorial being multiplied in there at the end. Raise your hand if you had that one right. Okay. If it was a P question, we wouldn't have needed this at the end. If it was a P question. When would you use just a P? If the order matters. All right, so now it's the same question, 30 kids in class. How many different president, vice president combos are there? Notice, the order matters now. 30 of you. How many different president, vice president combos could there be? You may type it directly into the calculator if you want to. In the back, you have a headphone in. Remove it, please. Thank you. And you still have your hat on. Gotta use that thing. That's great. Okay. So, 30 P2 is all there is to it. Raise your hand if you had that one right. Okay, good. Next kind, you have a group that's got subgroups in it. That could be deck of cards that's got hearts, spades, clubs. It could be a group of people like this that has boys and girls. It could be a group of people like this that has sophomores and freshmen. Get what I'm saying? All right, so let's say the whole school is a big group, subgroup, there's tons of subgroups within a school, right? You could split them up in a million different ways, but I'm going to say freshmen, sophomores, juniors, seniors, right? So let's say there are 3,200 people here at Minnetonka High School. And on this one, don't type it in your calculator because the number is going to be just ridiculously large. I want you to just write out what you would type in the calculator to get this answer. There's 3,200 kids here. Do you get that the principal has a group of kids that help him decide like how to improve the school? All right, so he's got this group. Let's say that he wants 2 freshmen, 2 sophomores, 2 juniors, and 2 seniors. He wants 2, 2, 2, 2. What haven't I told you that you'd need to know to be able to do this question? Yes? Does the order matter? The order does not matter. This isn't like president, vice president. It's like a big committee. Okay, so you have 2 of each. 2 freshmen, sophomores, juniors, seniors, but I still haven't told you enough. Yes?
Like how many?
All right. Is 32 divisible by 4? Then there's equal numbers of freshmen, sophomores, juniors, and seniors. So you'll have to do the math to figure out how many freshmen there are. How many sophomores are there? How many juniors, etc. Figure out the probability. No, not probability. How many different committees can he have if he needs 2 freshmen, 2 sophs, 2 juniors, and 2 seniors on the committee? How many different committees are there? Notice this is not a probability, and as soon as it is, you're just going to divide by all the things that were possible. But for right now, how many different groups are there? And this is a CC question. Because the order didn't matter, you're using C's. The reason it's CC is because there's a whole bunch of subgroups. If it was just 3,200 C8, it would have been a lot simpler, but that wouldn't factor in all the little subgroups. All right, did you figure out how many there were of each kind? 800 of each. And if this is a CC question, it's actually a CCCC question. And what do you do with choices? Multiply them. 800, choose 2. 800, choose 2. 800, choose 2. And 800, choose 2. Now, if there is 4 things like that all being multiplied together, couldn't I have said 800C2 to the 4th? I could have, couldn't I? I'm not saying you should have done it that way, but it's the same thing. When you're timesing it by itself 4 times, that means to the 4th. All right, now let's do one where there's CC, but it's probability. So therefore, it's divided by what was possible. All right, let's do a card question for this. All right, so you have clubs and not clubs in the deck, right? Let's say that you're going to get dealt 5 cards. What's the probability that you're going to get all clubs? Remember, it's something that's subdivided into groups. So it's CC over C. Probability, you're going to get 5 cards dealt to you, and they're all going to be clubs. If you play poker, you'd know that's a good hand. Do you guys know what it's called? It's called a flush. A straight would be if you had a run like 2, 3, 4, 5, 6. And 8, 5 numbers in a row. A flush is where they're all the same suit.
Wait, was the last one over 3,000?
The last one was not a probability, and therefore not divided. This one is a probability. All right, C over C. Raise your hand if you knew that we were doing that kind. Then, was it 13, choose 5, and 52, choose 5? Well, kind of. There's one other thing that you would have really wanted to do, and that would be the not clubs. You get by logic, we can figure out how many this number is, because this plus this has to equal this. All right, so you should have said 39, choose 0. But that's just, it's not even necessary because this one happens to equal 1. I'm going to do another one where it would have been necessary. No help on this one. Just see if you can do it. You're going to get dealt 5 cards. What's the probability you're going to get 4 jacks? Probability. Probability of 4 jacks. If you get dealt 5 cards, what's the probability you're going to get 4 jacks? CC over C. 4 jacks. 5 cards get dealt, you're going to get 4 jacks. All right. CC over C. Did you have, for the jacks, 4, choose 4? Raise your hand if you had that one right. Now, I did this problem to catch people who think they don't have to do the second one, but you do. It's out of 52, choose 5. Do you get this does not balance? Because 4 plus, I don't even have a number here, isn't making 52. And for sure, this part's a problem. 4 plus, I don't have a number here, equals 5. I need a number there. It's got to be a 1. That make sense? And then this other one has to be a 48. So it's 48, choose 1. 4, choose 4, times 48, choose 1, all over. 52, choose 5. Any questions on that one? Yes? Why is it a 4 here? Because we had 4 jacks that are possible and 4 that we wanted. We wanted all 4 out of 4. There's only one way to do that. So 4 choose 4 actually equals 1. If you want to save some time on typing it in, that's equal to 1. Okay. Next, let's move to, there is a pizza place. And at this pizza place, they serve 2 different kinds of crust. You know, a lot of places have a thin crust option. Thin crust or regular. Okay, so they have 2 kinds of crust, and they have 10 other toppings. Assuming you can only have 1 kind of crust, right? Because you can't have 2 kinds at once. But you can have a 2-topping pizza on this 1 crust. Tell me how many possible pizzas there are. And then, what's the probability that they'll give you your favorite one? Two kinds of crust, 10 toppings. You're getting a 2-topping, za. And I want to know, first of all, how many are there? And then what's the probability you'll get the one you want? For me, I think it would be a thin crust with sausage and pepperoni. I think that'd be my favorite. I'd like a lot of different combos, but all right, I'm going to pause while you try that one. Did you have 2C1 at the beginning? Because there was 2 crusts and you choose 1. And there were 10 toppings and you get to pick 2. And then what do you do with choices? Multiply. Raise your hand if you had that one right. Good. Then what's the probability you get your favorite one? Well, there's only 1 that's your favorite one. Okay? And I already told you what I picked ahead of time. It was a thin crust with pepperoni and sausage. 1 out of all that. It's very unlikely because there's so many choices. So if you're just trying to guess what your friend might, yeah, but that assumes everything's equal. You get some toppings that are pretty unlikely to be chosen in the real world, like anchovies. Has anybody actually had an anchovy pizza? Ever actually had it? You had it? It was not good, he says. Okay, yes. Salty, yes. Okay, all right. There are people who actually like the Hawaiian, and that's the Canadian bacon and pineapple. I'm one of them. I like it. I wouldn't order it, but if it was there on the table, I would eat some. How many of you would eat some if it was there? All right. How about the dessert pizza? Oh, these are so good. Yes, I'm definitely all in. If you haven't already tried this at Punch, how many of you have been to Punch before? All right. You have to like Nutella. How many of you like Nutella? Okay. You should try their dessert pizza. It's made with Nutella. It is so good. It's just incredible. Okay. Next one. Yes, question. Listen, please. Listen, please. Go ahead. Stop talking. Go ahead. Okay, because there was only one thing that you wanted. For a pizza question, when would you do CC over C is the question. All right. If your pizza had, okay, I'm trying to think of one that I could make into a CC over C for pizza. Okay. See, it has to all be able to be combined into one big thing. Okay. So, like one big set of choices. Okay. So then we have to have the pizza only offer 10 toppings. Okay. And they just offer 10 toppings. And you are going to take 2 of them. Okay, so that's the bottom of my CC over C. Now I'm trying to figure out how we would word a question like that if it was a pizza question. How many, or what's the probability that they would have the kind of crust that you would like? Well, then there were 2 crusts, but you would only get 1 of them. But then that's going to be, no, that's not going to work, because then that's just saying how many different pizzas are there with that one crust. Yeah, I don't know how I would do one like that, so therefore, don't worry about that. All right, let's do another one that involves the warranty kind of questions. These are expected values. These smart boards that I am writing on cost about $3,000. Let's say that the company is deciding, okay, we should offer some kind of a warranty plan. They are figuring out like how much they should charge for their warranty plan. And somebody says, all right, I think we should charge them $100 for the warranty. I think it should last for 2 years because it's most warranties do. And then I think we should try to price it so we make a little bit of money, but not a lot. All right, what other info do they need to know to be able to do one of these kind of expected value questions? Yes? Probability it's going to break. Now, they don't really know, but they think that they're going to have 5% breakage. In the first 2 years, they think 5% of them are going to break. So then my question is, if they price it at $100, and what the people get is a full like $3,000, they get a brand new smart board worth $3,000 if theirs broke. And the question is, was the $100 warranty priced at exactly the expected value? Or are they going to make a little bit of money? Or is the customer going to make money? What I would do is figure this out from your perspective, the customer. You're buying the board for $3,000 and you're trying to figure out, is my expected value positive or negative? From your perspective, if it's positive, that means the company loses money. If your expected value is negative, that means they made money. All right, so figure out your expected value, and by that, you'll know if the company priced it the way they wanted to. The company was trying to price it so they'd make a little bit of money. 2 things could happen, and it involves P times A. See if you can remember how to do this kind. I'll pause, we give it a shot. Okay, we don't have a ton of time, so we got to get to work. This is either it works or it breaks. Those are the 2 things that could happen. Raise your hand if you had that part right. Okay, what's the probability that this thing breaks? 5%. Then, therefore, you can figure out the other percent really easy. What's it? 95. How much do you get if your smart board keeps working? 0. And then how much do you get if your smart board breaks? 3,000. Now I know in the key, a lot of times here is where they would subtract the cost of the warranty on both parts, but in my opinion, not a great idea because the way it is right now, it's super easy. You just multiply by 0 on the top, gives you 0. You multiply across the bottom here, I can do that in my head, it's 15, but I got to put the 0 in the right space. Do you think it's $150 or $15? Which would it come out to be? 150. And then I go P times A and then I add them up. The value of this warranty was $150. If they charge $100 for the warranty, this is where I would like to subtract the $100 that I have to pay for it, and then I see, is it positive or negative 50 that's left? Positive 50, that is your expected value. The customer is going to have an expected value of $50. That's good for the customer, but bad for the company. Do you see what I'm saying? So then they priced this wrong. They probably should have priced it at $200 for the warranty. Then they'd be making 50 bucks instead of the customer making 50 bucks. Okay? Now I know there's a lot more to this in the real world. In the real world, when they actually sell a smartboard for $3,000, the company might be able to replace their smartboard way cheaper because they make them, right? They're cheaper for them. So that would decrease the costs, and so maybe this isn't that badly priced, but bottom line, only thing I could see you goofing up is, do I put the 100 in here? You could do it. It's okay. You'd have to subtract 100 from both of these, and it makes it a little more complicated math, but in the end, the answer is 50 either way. Okay. Do you want to do another like that, or are we good on that? Raise your hand if you think you've got that. You're not going to need any more practice on that. Raise your hand if you think you might need to practice that a little bit more. All right. We're going to do one more quick one then. iPads are now 300 bucks. They start offering a replacement plan for 50, AppleCare, you know, and this is the warranty. And let's say there's 10% breakage. Should you buy the warranty? And the answer would be like, yes, because the expected value is positive, what? Or no, because the expected value is negative, what? $300 iPad, warranty's 50 bucks, 10% of them break. Set this one up real quick, and if you just get it set up right, we'll say that you got the right answer, because it'll make it go faster that way. Pausing while you give that a try. Okay, works, breaks. The break percent, 10%. Working then, 90%. Probability times the amount. How much is the amount you get if it works? Nothing. If you want to do it the slow way, you would subtract the $50 warranty price right there, but I don't think you should do that to the end. Then the break. If you break it, you get $300 worth of a new iPad. Multiply. That's 3, but it's actually $30. Add them together, you get a value of 30, but we haven't paid for it yet. Now is when we subtract the 50. Negative 20 is our EV. That's how it would be in the real world. You're going to probably be losing money by buying the warranty because the company wants to make money. So your expected value, negative 20. What's the company's expected value? Positive 20. Okay. All right. Enough about that. Let's move on to other types of questions. All right. Let's say that you've got this coin that has a 55% chance of coming up heads. You tested it. You flipped it like 1,000 times. And it comes up 55% heads. Because they designed it a certain way. Okay, so here's my question. If you get 3 flips of this coin, what's the probability it's going to come up 2 heads? Does it feel likely to you? It does feel likely to me because it's supposed to come up heads more often, right? 3 coin flips. Now, whenever you see one where it's like, they gave me a probability, and now they want the probability in the probability, that's one of these. Did you guys recognize it was one of these? All right. So, probability of 2 out of 3 being heads. All right, I'll pause for a second while you give that one a try. So I was asked, could you have made a tree diagram? Yeah, anytime you're doing binomial, they're basically a shortcut of a tree. And so yeah, there is a bunch of paths that would work on this tree. In fact, how many? There's 3, choose 2 paths. That would have worked. And the 2 goes here because that's the ones that we were focusing on, which is heads. Obviously, the other side of that is tails, so that's over here. Heads was a 55. Tails must have been a 45. And then last but not least, this number, which clearly is a 2. Raise your hand if you had the same thing as me. Oh, I gotcha. A couple of people raised their hand. What's wrong? I did one on purpose wrong. Is that a 2 at the end? What is it at the end? It's a 1. Now, how many of you did it that way? Okay, that's better. Okay. Any questions? How many of you got that one right? Raise your hand if you got that one right. I got to just get this perspective. Okay. All right. Now, let's do one more like this. The guy is incredible at free throws. He has just practiced and practiced and practiced. He's a 95% free throw shooter. He gets 2 shots at the end of the game. What's the probability he makes at least one of them? 2 shots at the end of the game. So it gives you a probability, and then it's asking a probability question about that. Then you can know it's one of those kind where you use the binomial formula for it. 95%, and he wants to make at least 1 out of 2. Now, there's 2 ways you could do this. You could figure out probability of 1, probability of 2, and it's either 1 or 2. And what do you do with ORs again? Add them. If you don't like that way, there's actually a faster way to figure this out than that.
I think I did the faster way.
If you did the faster way, tell me how you started it. Yeah. Uh-huh. What if he misses both? I like it. Then how would that go? 3, he's got 2 shots, choosing to make how many? What you just said was, what if he misses them both? You're right. That's the smart way to do it, but you got to know how to set it up. That means he has 2 and he makes 0 of them, and the make percentage was 95, and that goes to the 0, and that means the other percent is 05, and that's to the what? That's the chances that he would make 0 shots. Now, really, if he's that good, do you get it's unlikely that that would happen? Okay, so we figured this out, and let's say it comes out to 1%. Then what's the actual answer? 99%. Okay, in this case, what is this answer? In other words, what is this? Just, if you type that on the calculator, be 0.00 what? 237, okay. Then we subtract that from 1. 1 minus that. So it's, oh, somebody did the 00237 wrong, okay. 0025, thank you. Then you have 0.9975. That means there's a 99.75% chance that they would do that. They would get at least 1, which makes sense. They're so good, you'd think they'd get at least 1. Okay. Now let's move on from that type of problem to the blanks. When do you make blanks on your paper? Remember the license plate questions? Let's say that you have a license plate and it goes like this. It's not these exact letters, but it would look kind of like that when it was done. Assume that you have, oh, okay. Is that actually a gun, AK-4? I think it is. Okay. All right, I'll change it so people aren't disturbed. Okay. I was thinking AK for Alaska, and then I just made up a random number. All right. So, here's my question. How many different, quiet please, how many different license plates could they make that are like that? And that assumes that letters can be repeated. Then figure out a separate answer, assuming letters cannot be repeated, because that's a different answer. Try it once where letters can be repeated, once where they cannot. Remember to think of these as choices. And then what do you do to choices? Multiply them. All right, Dice of Destiny. Row 3, person 4, EL. You got this.
Can be repeated, right?
And the first one, they can be repeated, yes.
Okay, so it would be 26, 26,
Good. And some people get confused that there's only 9 numbers, but when you include 0 and then 1 through 9, there's 10 choices. So that's good. Tell me the other one where you cannot repeat. Awesome. All right, now let's do another case where you'd use blanks. You have these books that are going on a shelf. And there's 7 of them. 7 books on a shelf. 2 of them are really long, big, tall books. You want to use them as bookends. They have to be on the ends of the books. The smaller, shorter books are going to be sandwiched in between them. Okay? So you got 7 books, 2 of which are really tall. How many different ways can you arrange them so that the tall ones are on the ends? Again, it would look kind of like this. 1, 2, 3, 4, 5. There. There they are sitting on the shelf. How many different ways can you arrange 7 books on a shelf if the tall ones have to be on the ends? All right. Who you get? We have 1, 2, 3, 4, 5, 6, 7 blanks. And how many choices do we have for this end? 2. How many choices for that end? 1. Then, how many choices now? Because we've already used up 2 of my 7 books. 5, 4, 3, 2, 1. All right, let's do another one like that. I got 2 kids that are really good on your little league team, okay? And you're in charge of setting up the batting order. There's 10 kids, but all you really care about, because your team's terrible, so they're only going to bat the first 5 people are going to ever get up. So all you really care about is, who do I bat for the first 5? You got 10 kids, and 2 are good. Like, they're really standout good. You know they're good. And you therefore want to put them in the front of these 5 spots. The front, the beginning of the batting order. They're first. You generally want the people to get on base so they actually have a chance to score. So you want to bat them first and second. 2 kids that are good. The rest of them, doesn't really matter. You can just throw them in anywhere. Being a little heartless here, but that's kind of happens sometimes, especially when the teams where there's little kids. There's just one kid that's like so good compared to everybody else. All right, do you get that these first 2 spots have less choices? Because I got to put one of those 2 really good kids in these spots. How many choices do I have for that spot then? 2. How many spots for that? 1, because I already used the other kid up over here. Times, I have 10 kids total, so now I'm down to 8, 7, 6. Raise your hand if you had that one right. Awesome. Okay. Let's see. Let's say that you have a rectangle that is 12 by 10. Think about if I said this was the center of the rectangle. Do you get that would mean it is equidistant from both the top and the bottom, and from the left and the right? Okay. Then, if that's true, when I make a triangle that goes like this, you should be able to figure out the probability that if I were to throw a dart at this and I was guaranteed to hit the square because I'm at least that good. Now, to make it random, I don't know when I'm throwing the dart where the triangle is. Okay, but what's the probability I would get inside the shaded area? You might be thinking, but you didn't tell me how big the shaded area was. I did too, by telling you that this spot right here was at the center of the square. Told you a lot. I'm going to pause for a second while you try to figure out the probability of hitting the shaded region. All right, so it involves a couple things. First of all, were you smart enough to figure out that this was 6 and this was 5? Okay, then the next step, were you smart enough to remember that the area of the triangle would not be 30? It would be 30, and then what do you do then? Divide by 2, so it's actually 15. So then, the answer for this one is 15 is what you want out of, how much total area was there? 120. 15 out of 120. Now, I know some people think of this in a different way, and it's okay, but I'm going to just keep it, because we have not much time, keep it simple and say that's how I would do that kind of question. All right. How about a circle? What if you had to find the area of a circle? Will you know how to do that? All right. Do you need to leave early? Okay, go ahead. That's fine. All right. So the next one is let's see, we've done the binomial. We've done the blanks. Don't shut your iPads. We are not done yet. Just one person is leaving early. All right. So, a 5-digit number. This 5-digit number needs to be at least 90,000. How many different numbers are there? Notice I made 5 blanks. This 5-digit number needs to be at least 90,000. How many are there? Think of it as choices again. Just think of it as how many choices I have to put Bob and Jack in the beginning because they're good. That kind. It has to be at least 90,000. Can things repeat? Sure. It's just a number. How many different ways could you make a number that was at least 90,000? Do you get that this digit right here is the key to the question? If it has to be at least 90,000, then how many choices do you have for that first one? Only one choice. It has to be a 9. Does that make sense? Now, can you have any digit next? Yeah. Because it could be a 0, because it'd still be 90,000. Okay, or a 1 or a 2 or a 3, so any digit, right? So then there's 10 choices for this, times 10, times 10, times 10. All right. Yes? Okay, let's say it's at least 92,000. Just wait. This does change the question in a different way than you maybe meant, but I know you need to know this too. So let's say it had to be at least 92,000. Now, can you have anything for this second digit? No. How many choices do you have? Yeah, 2, 3, 4, 5, 6, 7, 8, and 9. That's 8 choices. And then for the rest of the digits, we don't care, right? Okay. All right. Got to move on because we're getting very close to the end here. Let's see. You're welcome to come in. Just stay quiet, please. All right, we have covered so many practice problems. I think from here, it really just boils down to you practicing at home. So your assignment for tonight is the review worksheet. That review worksheet has a lot of questions on it, but on the nights before tests, I really feel like you need to do all of them. I normally give you smaller assignments, but I don't want to be the guy who threw out one question and was like, that was the kind that was on the test that got me. Okay, so you really need to do them all. There's answer key. If you get stuck, if you're getting stuck a lot, that's a bad sign. Tomorrow is a morning. You can come in and get extra help if you wanted. I'm here on Thursdays. So, all right, that's all I got for you for today.